Lesson 55, solving systems of linear equations by graphing. Some vocabulary words first. A system of linear equations is just two or more linear equations containing two or more variables. And then we have a solution of a system of linear equations, just any ordered pair that makes all equations true. When we deal with systems of linear equations, we're dealing with equations that you've already used before. If you think of an area problem, length times width, that has two variables, the length and the width. The ones we're working with today, it's going to be in the y equals mx plus b format, so slope-intercept form. So here we want to identify solutions, which means where do those two lines meet? And so they're going to give us a point, and we need to check to see if that point works for both equations. So we're just going to use substitution. We're going to substitute the numbers in for x and y. So 2 is our x, 3 is our y, and we're just going to substitute them in our equation here. So I put a 2 in for x and a 3 in for y, and I end up with 2 equaling 4 times 3 is 12, 12 minus 10. 12 minus 10 is 2. 2 does equal 2. So yes, this works for that equation. What about for the second equation? Put a 2 in for x here and a 3 in for y here. So 2 times 3 is 6. 7 times 3 is 21. The other side is 27. 6 plus 21 is 27. 27 does equal 27. So yes, it's a solution. And because they work in both equations, it is a solution. So in order for it to be a solution, it must work in both equations. Our next one here, put a 3 in for x and a 4 in for y. So I have 2 times 3 plus 4. This has to equal 5. 2 times 3 is 6. 6 plus 4. 6 plus 4 is 10. 10 does not equal 5. So no, it doesn't work here. I don't have to go any further because once I have one no, I know it's not a solution. It's not a solution. Next example. 1, 2. Plug in a 1 in for x and a 2 in for y. See if both sides, if the left side equals 7. So this is 3 plus 4. 3 plus 4 is 7. 7 does equal 7. So yes, it works for that one. Next one, I put a 1 in for x. 7 minus 3 times 2. 7 minus 6 is 1. 1 does equal 1. So yes, that works. So yes, it's a solution. Last one on the slide. Put a 2 in for x and a 3 in for y. This is 6 plus 6. 6 plus 6 does equal 12. So yes, it works for this equation. Last one, put a 2 in for x. 7 minus 3 times 3. 7 minus 9 is a negative 2. 2 does not equal negative 2, so no, it's not. So no, it's not a solution. And last one's identifying solutions here. Put a 1 in for y, put a 5 in for x. Actually, I switched around. 5 in for y and a 1 in for x. So 4 times 1 is 4. 4 plus 1 is 5. 5 does equal 5, so yes, it works here. Put a 5 here, minus 3 times 1. Does that equal 4? 5 minus 3 equals 2. 2 does not equal 4. So no, it's not the solution there, so the answer is no. And put a 1 here, put a 3 here. 2 plus 3 does give you 5, so yes, that works. Put a 1 in for x, put a 3 in for y. 2 plus 6 does equal 8, So yes, it works. So yes, this is a solution. Now let's look at it with graphing. So first we're going to graph it, and then we're going to decide if there's a common ordered pair between the two lines. And we will know if there's a common point because the points of the two lines cross, and that would be our solution. So here, let's do the first one, graph y equals x plus 3 and y equals 2x plus 1. So y equals x plus 3. I do the y-intercept first. So a positive 3. My slope is a positive 1, so I can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, or down 1 to the left 1, down 1 to the left 1. Now that I have many of my points, I can draw my line. So that's this one here. Let's do this one here. So put a point at positive 1 on the y-intercept, or the y-intercept. Slope of positive 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You can see my points here. I can now draw my line. They cross right here, so that solution would be 2, 5. So I can put that over here. 2, 5 would be the solution to that one. Now I'm going to erase this and do the other ones here. So x plus 5, so put a point at positive 5, up 1 over 1, up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1, down 1 to the left 1, because I have a slope of positive 1. Then I can draw my line here. Then we'll use do the other line, so negative 1 here. So we have a positive slope of 3, so up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. And you just keep going until at least you cross the line or get past the line. See, I can see we're already on the line. Draw my line here. Crosses here. So that would be 3 and 8. So that would be our solution, 3, 8. Next one is graph these on the coordinate plane. So I have y equals negative 2x minus 5, so I put a point at minus 5. And I have a slope of a positive 2. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I'll go up 2 more to the right 1. There's my line. And the other one is y equals x minus 3. So put a point at minus 3. Go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. See where my line is. See where they cross. Cross at 2, negative 1. So that would be our solution. Now, if the lines would never cross, that means there is no solution. Next one here, we need to solve this one by graphing. But with the second one, we need to put that into y equals mx plus b format. So I'm going to subtract 2x on both sides. So now I have y equals a negative 2x plus 15. Now let's graph these. So the first one's at negative 5. And I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. The other one, let me draw that line here. Goes up to a positive 15. So I'm going to have to extend this. So 11, 12, 13, 14, 15. So I put a point at 15, and I have a negative slope 2, so I go down 2 to the right 1, 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 down 2 to the right 1. So you can see right here is where they cross. And that would be 5, 5. So the solution of this would be 5, 5. And the next one here, both we need to put into y equals mx plus b format, so subtract 3x. So this is y equals a negative 3x plus 9. This one, subtract x. 2y equals negative x plus 8. Divide by 2. Actually, divide both parts by 2, so y equals negative half x plus 4. Now we can come to our graph here and graph them. I'll need to extend this one because I got to go to positive 9. So this would be 7, 8, 9. Put a point at 9. Negative 3 is a slope, so down 3. 1, 2, 3 to the right 1. Down 3, 1, 2, 3 to the right 1. Down 3, 1, 2, 3 to the right 1. I'll go down 3 more. 1, 2, 3 to the right 1. So there's my line. Just connect my points. Next one, put a point at positive 4. Now I have a negative half slope, so down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. See where my line is? They cross here. So our solution would be 2, 3. And this next one, put them in slope-intercept form first. So let's subtract 4x on both sides. 3y equals a negative 4x plus 1. Divide by 3. So I have y equals a negative 4/3 x plus 1/3. And here, subtract 7x. And I get y equals a negative 7x plus 6. Now I'm going to have to draw a coordinate plane here. So let me just draw our line here. We'll just use a solid line here. And since I have on the x-axis, I'm just going to count by ones. So we have 1, 2, 3, 4, 5, 6. And then we'll go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, negative 7. And we'll go down 1, 2, 3, 4, 5, 6, negative 7. Now we can plot our points. So here we have a positive 1/3. Positive 1/3, that's less than halfway. So we'll put that about here. And then our slope is a negative 4/3. So I need to go down 4. So if you go down 4, I can take my 1/3 and subtract 4. That would give me like about a negative 3.6. So I got to go past the negative 3. So almost to the negative 4 part. And then I got to go to the right 3. So roughly here. If I go down 1/3 again, or go down 4 more, I can't go down there. So I have 2 points and go, or I could go up. I can do my 1/3. 1/3 plus 4, or 12 thirds. 12 thirds plus 1/3 gives you 13 thirds. 13 thirds would be a little over 4. And then to the right 3. We'll be about right there. So now you can draw our line. And the next one we have +6. +6 here. Got a negative slope of 7, so 1, 2, 3, 4, 5, 6, 7 to the right 1. Down 7, 1, 2, 3, 4, 5, 6, 7 to the right 1. The lines would be, oh, that's off a little bit. To be crossing about here, we could say that would be about 1, 1. But to double check this one, because we have a fraction, we can use our calculator. And there's a slide, the next slide will show you how to use a calculator, but we'll do this one as well. So I hit the y equals button. I'm just going to type in my equations in slope-intercept form. So in -4 thirds, this is our x, plus 1 divided by 3. The other one is -7x plus 6. And if I graph them, you see at one point there, the other point right there, so ours is fairly close to what we had. Now to find the intersection point, I hit the second button, I hit trace, and I'm looking for number 5, intersect. Hit 5 and you'll see a blinking cursor right here, that's for that first line. I hit enter. The second curve, it's giving us the y-intercept right there. I hit enter. Guess just tells us, okay, yes, I want those two lines, see where they meet. And where they meet, 1 and -1. And on ours, I forgot to put the -1 on my y-axis. So this is 1, -1. That's a way you can always check with your calculator. Next one, here we're going to do the same thing. Use our graphing calculator on here. But first, let's put these in y equals mx plus b. So I need to subtract 2x on both sides. So I have y equals a -2x minus 2. And this one's already y equals -3x minus 5. So I grab my calculator again. Go to my y equals, clear these. And so I have -2x minus 2. And the other one is -3x minus 5. Hit graph. See our 2 points. They cross about right here, but to be specific, find out what it is. Click second, trace, number 5 for intersect. First curve, hit enter, it's on that one line. Hit the second curve, hit enter, and hit enter a third time. So the intersection point is -3, +4. So that would be our solution. -3, +4. Now let's look at some application problems dealing with word problems. Bo and Celine decided to rent bikes. There are 2 bike shops from which to choose. Rent a Bike charges $10 per hour per bike. Bike-A-Rama charges only $4 per hour per bike, with a deposit of $15 per bike. At what number of hours will both shops charge the same amount? And what is that amount? So first off, we need our 2 equations. So rent a bike charges $10 per hour. So y being your total cost and x being the number of hours. And then Bike-A-Rama charges $4 per hour per bike, but then they also have a $15 fee per bike. So those are our 2 equations there. We're going to graph this using our calculators here. So I go to my y equals button, clear. and put our two equations. So this would be 10x. And the other one is 4x plus 15. And then I can graph them. And you can see that it's off here. So I'm going to hit the zoom. Let's zoom out. So number 3 didn't zoom out as much, so I'm going to change on my window. Let's do our max for our y. Let's make this 20. And then let's try graphing it now. Actually, let me go back down. Keep the x the same. It's the y. The y we have to go. I'm going to make this 30. The y axis, the max is 30. Then graph it. There you can see where they cross. So hit second, hit trace, number 5. Enter once, hit enter a second time, hit enter a third time. And it tells you 2.5 equals 25. What that means is after 2.5 hours, they both charge the same amount. And the amount that they charge is $25. So this is your x and this is your y. So at 2.5 hours, they both will charge the same amount, which is $25. So these would be your answer. That's your ordered pair. Next one, Jill has $20 in her savings account and plans to deposit $5 each week. Jose has $5 in his account and plans to deposit 10 in each week. After how many weeks will they have the same amount of money in their accounts, and what was that amount? So Jill has $20 in her account, and she's going to deposit $5 per week. So 5x plus the 20. And Jose is depositing $10 per week, and he starts off with $5 in his account. Again, I'm going to use my calculator here. I'm going to graph it, hit the y equals, clear everything, back up here, so 5x plus 20. Second one is 10x plus 5, and we can graph them. You can see it's off a little bit, so let's change our window. Need to come down to the y maximum, and let's just say we'll go 35. Then graph them. Hit second trace, number 5, hit enter 3 times, and it says 325, which means after how many weeks? After 3 weeks, they will each have $35 in their account. And the last question here. Alex and Brett need to decide to open savings accounts. There are 2 banks to choose from near their school. Bank A gives a 4% annual interest rate and currently has a promotion where $10 bonus is given in an amount of $1,000 or more is deposited initially. Bank B offers no special promotion but has a higher annual interest rate of 5%. With an initial deposit of $1,000, how long will it take for both banks to yield the same return? So for this one, we're going to do a little bit different. We're not going to graph it. We're just going to take 4%. So for Bank A, you get 4% for every $1,000 you put in. So they've put in $1,000. Plus, they get $10 extra for putting in the promotion is for every $1,000, you get $10 a bonus. So if This is 4 times 1,000, because you're putting that initially in there. So this is for 1 year. For 1 year, 4% of 1,000 would be 40. 40 plus 10 gives you $50. Now bank B, for 1 year, you get a 5% interest, and they initially put in $1,000 in there. So 5% of 1,000 would be $50. So they're both at $50 after 1 year. So how long will it take for them both to yield the same return? 1 year, and that amount would be $50. So that way we can just use basic math and what we know about how to find percent of a number. So that's our lesson today on graphing or solving systems of linear equations by graphing.